This podcast goes over a couple graphing guidelines because we're going to be moving away from doing a histogram for every single experiment, and several experiments that we do going forward, you'll be making a line graph. So this kind of reviews some basic line graphing guidelines. And another good reference is textbook section 3.3 if you feel like you need more advice once this podcast is done. Please write down these guidelines so that way right in the middle of lab 3.2 you're going to have a little section that says graphing guidelines, and then below it you're going to make your graph for experiment 3.2. So first rule of thumb is to use either a whole page or use a lot of the page. A lot of the experiments we do, you're going to have a lot of data that has a fairly large range, so it makes sense to use the space that you need to show it well. For my example graph I'm showing you, I graphed this temperature data, and this is the forecasted temperature for today, which is Tuesday, January 6th or 7th, 2014. Another huge guideline is to title your graph. Tell the reader what your graph is a picture of in your title. So here you can see I had the title weather graph. That's a bad title. It's just too vague. It doesn't tell me what weather I'm graphing. Similarly, 3.2 graph, way too vague. Instead, tell your reader what's on the graph. So I said temperature and time, because those are my two variables, for two cities. My two cities here, Boston and Worcester, and then I said what date it was for. This is a much better title because it tells your reader exactly what is on the graph. Next thing you need to do is label your axes. When you label your axes, make sure you both say what's on the axis and give units. So for example, I put temperature in degrees Fahrenheit, and then I have time, and I labeled AM and PM here. Also choose intervals that make it easy to plot the data. So I counted up by ones here when I did my temperature axis, and I also counted up by 1 hour when I did my time. Don't get fancy and try and count up by 1.5s or 0.33 or 3s or 7s. It's much better to count up by 2s or 1s or 5s, something that's really easy to plot the data because it's easy for you to estimate where those points belong. If you're graphing more than one data set, use a different color for each and provide a key. So I used orange for Boston and pink for Worcester and plotted each in that color. My key over here tells me which is which. Now this next one, I've been telling you to use a ruler all the time, but this is an exception. So when you're connecting your data points, connect them with a smooth curve. So you don't need to take your ruler and connect straight from point to point. Instead, just kind of eyeball it and connect them with a smooth curve. And you'll notice that your curve doesn't have to go through every single point. Like down here, I didn't go through every single point. It should just show the overall trend of your data. Finally, when you're trying to figure out what goes on what axis, often the textbook is going to say graph this as a function of that. So blank as a function of blank. It tells you what to put on which axis. It's always y as a function of x. So whatever comes first goes on the y-axis. Whatever comes second goes on the x. So for instance, this graph here on the left, if I'm plotting temperature as a function of time, then temperature goes on my y-axis and time goes on my left axis. This graph tells me how temperature changes when time changes. This one on the right, I have a hypothesis that as you get older and your grade level changes in school, the length of the book you read in English class might change. So graph is going to be length of book as a function of grade. So on the y-axis goes length of book in pages, so how many pages are the books you have to read for English. And then on the x-axis goes your grade, 5th, 6th, 7th, 8th, etc. Now these two variables, the one that goes on the y and the one that goes on the x, have names. The independent variable is the one that goes on the x-axis. This is the one that you control or that you change. So here, time is what's changing, and then we want to see if temperature changes based on time. On the right, grade level is what's changing. We want to see if the length of book changes or not. That variable, the one that goes on the y, is called the dependent variable. This is the one that might or might not change depending on what happens with the independent variable. So for instance, if you change grade levels from 6th to 7th to 8th, maybe you read longer books, maybe you read shorter books, or maybe there's no effect. So grade is the one that you're definitely changing. Length of book is the one that might or might not change depending on what happens with this variable here. Going back to my weather graph, temperature was the dependent variable and time was the independent variable. Okay, now that you have these guidelines, use them to make a nice graph of your data from experiment 3.2. You're going to have multiple data sets, so you'll need to have different colors and a key. Don't forget to do the title. Use most of the page, label your axes, pick an interval that makes it easy to plot, something nice and even like 1 or 2 or 5, and have fun.